We're studying IGCSE chemistry and we're starting chemical reactions in Equilibria 4. Now, in today's class, we're going to practice a lot of questions and revise whatever we have missed. Now, we have finished the syllabus, so practice is what comes after that. Let's start with the first question. Zaira, read the question.
Ammonia is manufactured by the heavy process. Nitrogen and hydrogen are passed over a catalyst at a temperature of 450 degrees Celsius and a pressure of 200 atmospheres.
Okay, next.
The equation for the reaction is as follows: nitrogen 2, 3 hydrogen, and 2 NH2. Okay. The forward reaction is exothermic. State 1, use of ammonia.
Yes. I want the answer from Zahra. Niranjana, can you hear me?
Yes, I can hear you.
I want your answer in the chat for question 1A. Zahra, say the answer to me.
Reaction is exothermic. Sir, what do I have to tell here for
Use of ammonia. One use of ammonia.
when use of ammonia?
Right. Okay. I've gotten. Okay. Niranjana, tell me the answer.
Sir, I wrote it in the chat.
Say it out loud.
To make nitric acid,
Yeah, making nitric acid. There's another one. Tell me one more.
to make fertilizers,
Making fertilizers. Now, whenever you have these two options, you should prefer the fertilizers option, but both of them are correct. Yeah. So perfect. These are the two options. Yeah. So you can write both, but see, not in this case. They're telling us to write one. Okay.
Oh.
So you should only give one, but both of these are fine. I'm going to give you, yeah, both of them are fine.
Sir,
Yeah,
but for preparing fertilizers, we just use 3, right? One is nitrogen and potassium and phosphorus. How come it's nitric acid then?
No, this is the use of ammonia. Now, we talked about this, that ammonia, after we produce it in the Haber process, we especially use it to make fertilizers. What kind of fertilizers? One of them is NH4, SO4, 2. This one, ammonium sulfate. The other one, the other fertilizer is NH4, NO3. So ammonium nitrate, ammonium sulfate, these are the fertilizers. So we need ammonia to make fertilizers. Okay. Please, so write this down in your notebook now, uses of ammonia, Zahra, and then watch the recording of the previous classes, right?
I still have a question.
Ask me.
For making fertilizers, we use ammonia, right? But here in the book, I read it was phosphorus, potassium, and nitrogen.
Yeah, we do need those things, but we don't use them to make it. It should be there in our, let's say, it should be there in our fertilizer, but we don't use it to make them, right? How do we get the nitrogen? To get the nitrogen, we use ammonia. Ammonia plus, let's say, phosphoric acid. And then this will give us ammonium phosphate. Right, this whole process of making the fertilizer, we need ammonia here. Okay, now whatever you've read in the book, that's okay. We'll revise more fertilizer questions. All of this is about fertilizers only. So just we'll do more questions. Hopefully your questions will be answered. Just revise the previous lessons. Okay, now write this down in your notebook. The two uses of ammonia. 1, 2. Niranjana, read the next question. Zahra, any other questions?
What is the meaning of the symbol reversible?
Reversible, okay, reversible. But so not just reversible, but reversible reaction. Is that clear?
Reaction.
Now there's another one you could say, which is equilibrium.
Okay.
And I would prefer if you use the word equilibrium. Or don't use equilibrium, just use reversible reaction. Both are fine. Fine. Zahra, any doubts in this? This symbol, the arrow, means reversible reaction. Okay. Now, Zahra, read the third question, part C.
What are the sources of nitrogen and hydrogen used in the Haber process?
Right. I need the answer from both of you in the chat.
Okay, in the chat.
And so just send it privately. Yeah. There should be an option to just send it to me.
Sir, after nitrogen, what was it?
Say that again. After nitrogen, we have hydrogen. What are the sources? Okay, nitrogen. Got it. Zahra, I got your answer. Niranjana, I'm waiting for your answer.
Is it correct?
Yes, the first one is correct. What is the second one?
Sir, I'm not sure about the spellings, but yes.
Yes, that's correct. Niranjana, say your answers. Meanwhile, Zahra, do the fourth one, part D, in the chat. All right, that's correct. Now read part A. Do part A and send the answer in the chat.
Okay.
Niranjana, can you hear me?
Yes, I can hear you.
So what is the answer for part C?
So for part B, it is iron.
Iron, okay. Part C.
Part C, oxygen from the air and hydrogen we will get from methane gas.
Yeah, so not oxygen, we have nitrogen. So nitrogen from air, and this is from methane.
Hydrogen from methane.
Okay. Now read this question, Niranjana.
Okay, sir.
Sir.
If the temperature higher than 45 degrees Celsius was used in the Haber process, what would happen to the rate of reaction? Give a reason for your answer.
Okay, Zahra, answer.
Okay, so it's, sir, we have to rate the reaction, right? Like, is it exo or endo? Is that how we will rate it?
Now, no, so the thing is, yeah, we know it's always exothermic. We know that both Haber process and contact process is exothermic, right? So how do we write the answer here? Niranjana, any guesses? What they're asking us, what would happen to the rate of the reaction if temperature higher than this was used?
It would be higher.
The rate of reaction would be higher. Would be higher, but why? I need a reason. There are 2 marks, you need 2 points here. So 1 point is done. What is the second thing?
More energy will be released or taken in.
So not taken in. Particles will have more energy. That's what we say. So, or we don't say that. We don't really say that. What we say? More collisions.
NF3.
Not energy, collisions. Because we know temperature increases energy. That's the common sense. But something which specific, which increases the rate of reaction is, now this is in the previous chapter. You must have done this in school. That more collisions take place. And just say more successful collisions. Yep. Now please write this down. I'll tell you what to write down. Just a second. The question will be. The question is effect of higher temperature on rate of reaction. Now write this in your notebook and write the answer. These 2 points. Tell me when you're done writing. Now after this, there's another question they might ask you. That is effect of higher pressure, rate of reaction. Answer. Remove the word successful from here. Just say collisions. Answer would be yeah. So more collisions. All three of these, if you increase temperature, if you have higher temperature, higher pressure, or higher concentration, all of these have the same thing. Rate of reaction would be higher or would increase because more collisions take place, right? Let's say, yeah, more collisions take place.
Done writing.
Done writing?
Yes.
Now please add this word again. Successful. That's better. Okay, add it there.
Done.
Right. Okay. Increase. Fine. Fine. Done. Okay. Done. Okay. I'm giving you a few more notes to write down. Actually, we'll look at that afterwards when we get more questions like this. But this should be enough for now. Okay, for 2 marks, this is enough. We'll look at rate of reaction again when we do more questions on this. Now, Zahra, read the next question.
Okay. If a temperature higher than 450 degrees Celsius was used in the Haber process, what would happen to the yield of ammonia? Give a reason for your answer.
Yield. Now they're asking us temperature higher than 450. What happens on yield of ammonia?
There will be energy. Again, it will be decreased.
What will be decreased?
Energy.
Energy will be decreased.
But there will be no effect on it.
Okay, I want you to write the answer or on your notebook and send me a picture. Niranjana, do the same thing. Right now, please make sure to differentiate these. Whatever I'm asking you to write, those should be your notes, and the other practice answers should be somewhere else.
Practice of what, sir?
Niranjana, what is the question? The answer for E2, E part 2.
So increasing temperature will reduce yield, catalyst will also increase, or a catalyst does not influence position of equilibrium.
No, so the first part is correct, the second part is wrong. Now please write your
Why?
answer in your notebook and send me a picture so I can check the answer. Okay. Now you have
Sir,
exactly
I will get the phone.
you have exactly 1 minute.
So I have sent you the answer.
Okay, Niranjana, the thing is, this part about the cat, are they asking us about the catalyst? They're not asking us the catalyst, yeah? So you don't have to write this part is wrong. Don't write about the catalyst if they ask you about the temperature. Okay, and this part is correct. Good job on this. But you have to add one more thing here. Now, what is this? Why does this happen? You need to write, why does it reduce yield? We know that because of the first, look, I'll write the answer here and please see what the answer is. Haber process is exothermic. Okay, or let's just say forward reaction is exothermic. Increasing temperature, favors endothermic reaction. So yield will decrease. Now, before you write this, you should also write according to Le Chatelier's principle. Right. Is this
So I have
clear?
to write this.
Say that again.
So I have to write this over there.
Yes, you should write. This is what you have to write in this answer. The
Okay.
forward reaction is exothermic. Now, please don't write it like this. Let's try to understand. Niranjana, speak to me and Zara. Why is this the answer? First, read the answer, Zara.
Forward reaction is exothermic according to Le Chatelier's principle. Increasing temperature favors endothermic reactions, so yield will decrease.
Yield will decrease. Now we know that exothermic reaction. Zara, what does exothermic mean?
Giving out hot heat.
Giving out heat. So it is giving out heat, right? Exothermic. But okay. Just a second. Right. What we realize is, just remember this, exothermic reaction. For exothermic reaction, or let's just say low temp favors exothermic reaction. High temp favors endothermic. Now, because of this, now what is happening here? Our reaction is exothermic. And if you increase temperature in exothermic, then the yield will decrease because high temperature does not favor exothermic. It favors endothermic. Yeah. So that is why the yield will decrease. In the same way, high pressure favors side with less particles, or low pressure favors side with more particles. Now these are the 4 things we learned out, okay, in Equilibria, according to Le Chatelier's principle, that if you have low temperature, that will favor exothermic. High temperature will favor endothermic. Now in this case, what is happening? Are we taking a high temperature or low temperature?
High temperature.
High temperature. And what kind of process is Haber process?
Exo.
Exo. So if it is exo, then I need low temperature, but they're doing high. That means the yield will decrease. Okay. Is that clear? So that's it. Write this in your notebook. Favors yield of. Okay. Okay. Write in your notebook.
Sir,
Yes.
so yield is a product, right?
Yield is the product. Yes. How much concentration is, how much product are we getting? The amount of product. Niranjana, how much have you written?
Sir, I'm in the decreasing concentration, that one. Done, sir.
Done. Niranjana, Zahra?
Sir, just last line. Okay, done.
Done. Effective. Okay. Now one last thing. Effect of high temperature and exothermic reaction. You have to write this question on your notebook. Okay. And the reaction, I'll give you an exothermic reaction. Let's say NH3, sorry, N2 plus 3H2 gives us 2NH3. Now there's a classic, you need to know this by heart, this equation, right? Okay, so now read the question, Zara.
Effect of high temperature on exothermic reaction.
Yes, so how will we answer a question like this? Now another thing I'll tell you here that this reaction has a negative value, a negative delta H value. Delta H tells us if it's endothermic or exothermic, the enthalpy. So if the enthalpy is negative, that means it's an exothermic reaction, yeah, obviously. So the answer will be high temperature favors endothermic reaction. So equilibrium will shift backwards. Second point is, so yield yield will decrease. Okay, so what really happens is this line over here is important. This line. First, Niranjana, read the answer.
Okay, so high temperature favors endothermic reaction, so equilibrium will shift backwards. 2 yield will decrease for endothermic reaction.
Now read it again. You read it wrong. One more time.
High temperature favors endothermic reaction, so equilibrium will shift backwards. Yield will decrease for exothermic reaction.
Exothermic reaction. Now this guy is exothermic reaction. But the thing is, if I use the opposite condition, exothermic wants low temperature. We know that from here. If you use high temperature and exothermic, the equilibrium will shift backwards. Now this is very important. This line is 1 mark. If you don't write this, you will only get 1 out of 2 marks. Okay, there are 2 marks over here. 1 mark is for yield will decrease, the other mark is for this. Equilibrium will shift backwards. So please let's understand what's happening here. Write this down also in your notebook. But before you write it down, talk to me. Now, Zahra, can you hear me?
Yes, sir.
What's happening over here? We have N2 plus 3H2 gives us ammonia, right? Now, the forward reaction, what is the forward reaction? Exothermic, endothermic? The forward reaction, exothermic.
Yes.
The reaction is exothermic forwards, okay? Then what is the backward reaction then?
Endo.
Endothermic. So if the forward is exothermic, the backward must be endothermic. Okay, that's the backward. This is the forward.
Okay.
Yes?
Okay, how will they know that is it exo or endo?
They will tell you in the question, or they'll say this. If it is negative, then it must mean that's exothermic. Okay? Delta H negative means exo. Delta H positive means endo. Write this in your notebook. Okay, now Niranjana, listen, focus over here. Now, which side favors high temperature? Or which side does high temperature favor? Exo or endo?
Endo.
Endo. So this is the backward side, yes? So what will happen to ammonia? Ammonia will decrease, and this will happen. So this will increase. That is why the yield will decrease. Is that clear?
Yes.
Okay, because now it's going backwards. So this guy is decreasing, this is increasing. Let's try, I'll give you more questions. Now, have you written this in your notebook? Write it down and tell me when you're done. For any question in the exam, this is the format of answer you're writing. High temperature favors this. You should also focus, you should also say, just a second. So, according to Le Chatelier's principle, Lier's principle, equilibrium will shift backwards. Now, why am I asking you to write this thing? Because that itself will also give you a mark in the exam. Okay, extra marks, free marks, just for writing that line. Any question in equilibria, when they ask you the effect on yield, then you should say, you should mention Le Chatelier, mention his name.
Sir, so if the questions carry marks of 4, if we will add his name, it will be 5?
Now they won't give you extra marks, but what if one of your points was wrong? Perhaps you may get, if let's say you wrote 4 points, one of them was wrong. Maybe they will give you the mark for this one. Yeah, they won't give you marks more than 4, but if anything is wrong, they will ignore the wrong part and take the correct part only.
Okay.
After effect of, add yield, effect of yield. Okay, effect on yield, sorry, effect on yield. Yeah. Oh, not here, not here. Yep, effect of higher temperature on yield of
Done, sir.
done. Niranjana,
Done, sir.
done. All right. I'm going to give you another practice question before we get back to the past papers. I'm restarting the meeting. Rejoin. Read the question. Question number 2.
Effective flow temperature on yield of exothermic reaction.
Yeah. So what is the effect on this reaction right here? The delta H again is exothermic negative. How will we write this answer?
So it's like, so it's low temperature. Low
Yes.
temperature favors endothermic reaction.
No, check your notebook again. Low temperature favors what?
Exothermic, I'm sorry, yes. Low temperature favors exothermic reaction. So we will add, according to Le Chatelier's principle, equilibrium will shift forward,
Forward.
right?
So what happens? Yeah, perfect. Forwards. Then
And yield will increase, and then
that's
there
it.
will be, yeah, that's it.
So 2 marks. Easy. Understood. Good.
Sir, wasn't it for 4 marks?
It was for 2 marks. It could also be for 4 marks, right? So yeah, it's okay. Now this usually 3 marks. Just a second. Fine. Niranjana, tell me the answer to this question.
High temperature will favor endothermic.
Okay.
Wait. So
Sir,
low temperature favors exothermic.
Yes. Then what?
One point. So the equilibrium will shift forwards.
Yes. Then
Then yield will increase.
yield will increase. Is that clear? Okay, got it. Let's try
Is
the
it
next
correct?
question. That's correct.
Uh-huh.
Good. Good job. Now next one. This one. Now look at the question. Zahra, read the question.
if a pressure higher than 200 atmospheres was used in the Haber process, what would happen to the yield of ammonia? Give a reason for your answer.
Right. Again, we'll write the reaction here. First, tell me the equation for Haber process, Niranjana.
For Haber process,
Yes. The equation.
the equation for Haber process it is N2 plus 3H2 gives us 2NH3.
Yeah. All of them are gases. Fine. You don't need to write that right now. Next, what happens to the yield if you use a higher? What is happening here? So pressure higher than this. What happens to yield? Now you tell me, Zahra, what is the answer? Niranjana, write it in your notebook. So Zahra, what is the answer to this question?
Oh yes, I can hear you now. Okay, so the so I was having a question actually.
Ask me. Quick, just hurry up.
Sir,
Yeah.
okay. So if tomorrow we will be having exam, okay, she doesn't ask us this kind of questions. She give us products to change them, to reverse them, and I don't know how to reverse them at all.
Right. So guys, please tell me what kind of questions they're going to ask you. Right. Do you have any homework with any assignments with you?
No.
So okay, we'll look at that, how to change them. So just finish this question first and we'll get to that, right? Don't worry, we're preparing for the final exams. Those are more important. Let's first finish this and we'll do the other questions, okay? Now tell me the answer to this question, Zara.
Can you repeat it again?
Yeah, read the question. Part
Okay.
F1. What is the answer?
The answer is pressure. Okay, so the pressure is higher. It will favor endothermic reaction.
No, read your notebook. Read your notebook. What does high pressure favor?
Sir, high okay. Sir, high prefers, okay. High. I thought it's temperature. Okay, higher pressure favors less particles.
Less particles. So which side has less particles? Right or left?
I guess right. Left, sorry.
Left. Now you tell me how many particles
Yes.
of N do we have here?
2.
No, 1. Look at the number in front. Okay. That's 1 and 2 because N is bonded. That's a one particle, right? It's no, they're not two separate particles, they're one particle together. Okay, like this. That's one particle of N2. They're not separate. So we have one N2, we have 3H2. Okay. So what is the total on this side?
It's 4.
4. And how many do you have here? How many particles here?
5.
Not 5, no. Look at the number in front always.
Okay,
How
it's 2.
2. So which side has lower? Not 1. Again, see, there's no plus here. This is together. ये पूरा एक साथ में है. ठीक है? If this is together, then you just look at the number in front here. But over here, these were not together. This had a plus sign. Okay? So 2 and H3. So we have 2 here. Now which side has lower particles?
Right.
Right. What is it? We don't say right. We say forward or backward. Which side has more? Let's say which side has less particles? Forward or backward? Forward. So what is the answer? The format will be the same. So tell me the answer.
Forward pressure. No. Higher pressure favors less particles with forward reaction, right?
Yeah. So less particles. Then we'll write it here. So high pressure favors less particles, or we don't just say less particles. We say reaction side with less particles. Right, then what do we say? Whose name do we take? Le Chatelier. It's not Cha, it's Cha. So Le Chatelier's, yeah. Chatelier's
principle, equilibrium.
Equilibrium, yeah. Will shift
forward.
So what happens to the yield of ammonia?
It will decrease.
Decrease? What is forwards?
Forward is less.
No, okay, that's fine. Forward is less, yeah. So we're favoring forward. Now, what is being formed in the forward reaction? What product is
So
it?
it's increasing.
Increasing. Ammonia is being formed, yeah. So that it's favoring ammonia. So we'll say yield will increase. Increase for forward reaction, which is for ammonia. Ammonia is there in the forward reaction. Does this make sense? Everything is same.
Yes.
Now this is the rule which you write in your notebook. Okay? You have to memorize this. And this is also same. You have to memorize this as well. The only thing you need to realize is, will yield increase or decrease? Now this is forward reaction here. And they're asking us about ammonia. So if the reaction is going forwards, then you'll get more ammonia. Is that clear? If it was going backwards, then ammonia will decrease. But it's going forwards, so ammonia will increase. Is that clear?
Yes.
Niranjana, is that clear?
Yes, sir.
Read the next question, Niranjana.
Explain why the rate of reaction would be faster if the pressure was greater than 200 atmospheres.
Why will it be higher? Tell me. Read your answer, which I gave you for high pressure, concentration, and temperature on effect on rate of reaction. What was it? Check your notebook. Effect of high pressure on rate of reaction.
High pressure favors reaction site with lower number of particles.
No, but we're not asking about equilibrium. We're asking about rate of reaction. Now, this is not about yield. It's about rate of reaction. Yeah. High pressure. Does it decrease or increase rate of reaction? Okay, I'm going to ask you to read something. Niranjana, read this.
A very high pressure will be expensive and dangerous. So we take a 200 atmosphere.
Yeah. Now read this one. Effect of high temperature, pressure, and concentration on rate of reaction. Read this, Niranjana, out loud.
Effect of high temperature, pressure, and concentration on rate of reaction.
Right. Then read the answer.
Like or what I said?
Yeah, no, this one. The answer here. Rate of reaction.
Okay. Rate of reaction would be higher, more successful collisions take place.
So what do we write over here? Zara, tell me.
Okay, so because second, okay, there will be collision. So can we
simple.
just say that energy will be activated?
No. What we can say is pressure. High pressure increases rate of reaction. High pressure increases rate of reaction. Oh my God, just a second. High pressure increases rate of reaction. Why? Because more successful collisions take place. More successful collisions take place. Is that clear? Now you have written this on your notebook. The thing is, memorizing will not give you marks in the exam. I see what's happening now. I've given you so much to write, and you don't know what to write in the answer now because there's so many types of questions. So it is important that you read the question first and then answer. Understand what they're asking you. Okay. Now one more time, Zara, read the question.
Explain why the rate of reaction would be faster if the pressure was greater than 200 atmospheres.
Okay, so explain what are they asking. Explain to me what are they asking.
They are
Urdu में explain
asking,
करो आप. Urdu में. Say it in Urdu.
Okay, तो वो पूछ रहे हैं rate of reaction और okay, sir. Explain why the rate of reaction would be faster if the pressure was greater than. Okay, they are asking what would be the rate of reaction अगर pressure 200 atmospheres से ज़्यादा बड़ा होता.
बड़ा होता, राइट? बढ़ जाएगा तो क्या होगा? हम कहेंगे कि अगर रिएक्शन रेट ऑफ प्रेशर बढ़ जाएगा तो रेट ऑफ रिएक्शन ज्यादा हो जाएगा. क्यों? क्योंकि more successful collisions take place. They're not asking about yield. They're not asking about the Haber process or contact process or any process. They're only asking us कि अगर आप प्रेशर को बढ़ाओगे तो रेट पे क्या फर्क पड़ेगा, क्या इफेक्ट होगा. तो we will say अगर आप प्रेशर को बढ़ाएंगे तो rate will increase. क्यों? क्योंकि more successful collisions are taking place. Is that clear?
Yes.
Next question. Niranjana, read the question.
Suggest one reason why pressure higher than 200 atmosphere is not used in Haber process.
Explain the question to me.
We have to give one reason why we don't use higher pressure more than 200 atmosphere.
So what is the answer?
Because it is expensive and dangerous.
Yeah, easy. Yeah. So expensive and dangerous. Now they're just asking you for one. So you're giving two. They'll be happy. Dangerous. Both of these are correct. Okay. Fine. Now dot and cross to show the outer valency in the one molecule of ammonia. Please draw this in your notebook. Ammonia has, first we'll make this one circle like this. Just a
Sir,
second.
if they ask same for the contact process, then what will you say? Like, what will be the answer?
Why is high pressure now used? The answer
Yes.
there would be that again, it is expensive and dangerous, but the yield is already high for contact process. So first thing, you won't write this first. You'll write yield is already high and pressure is expensive. So that mark is there for contact process. But in Haber process, we say that expensive and dangerous. You need to check the recordings. Please check the recordings, okay? Before you sleep today, you'll have all the recordings in the YouTube or wherever in your GCR. Yeah. Increase the speed by, let's say, make it 2 times the speed and watch it. Because I've spoken about everything, right? The only issue is happening right now that you guys don't remember everything. So please revise and memorize. Now this is what ammonia looks like. Please draw it in your notebook. We have N in the middle and 3 H's. Like this. H, H, H. To here.
Sir, can you explain this question again?
This
I
one,
get it.
the
Yeah.
dot and cross. I see.
Yes.
Okay. So what's happening is simply they're asking us to show the bonding of ammonia. Okay. Now, what does ammonia look like? Ammonia is NH3. Yes.
Yes.
Okay. You tell me what is the group of N? Nitrogen.
It's 1. No.
No.
Yeah.
No.
No. Let me look. 3.
Group 3.
It's 5.
Group 5. Yes, so it is group 5. So how many electrons does ammonia have
It has
in the outer shell?
ammonia.
Nitrogen,
Sir,
I'm asking how many electrons does nitrogen have in the outermost shell? Niranjana, tell
it
me.
will be
Yeah.
-3.
It's going to be 5. If it's group 5, then you have 5 electrons in the outer shell. Is that clear?
Yes.
So group 5, so it has 5 electrons. Now I'm making these guys with circle, green. And let's just look at this. You have nitrogen here with N, and it has 5 electrons. So let's make 5. 1, 2, 3, 4, 5. Is that clear?
Yeah.
5. Now the thing is, it is bonded to how many hydrogen?
3 hydrogen.
3 hydrogen. So what really happens is nitrogen shares 1 electron with 3 hydrogens. And this is what it looks like at the end. Cross, cross, cross. How many? What is the group of hydrogen? Tell me.
1.
1. So it has 1 electron in the outer shell.
Yeah.
So this is what it looks like. This is the bonding. Is this clear, Zara?
Yeah.
Yes, sir.
Now please ask me if you have a doubt. There's nothing wrong with doubts. Now why does it
Clear,
have?
sir.
It's clear. So you have 2 extra electrons here. You need to show these here. This is called a lone pair. But they're not asking you this in this question, so forget that for now. Done. Okay. Let's move on. Now you tell me, what kind of questions is your teacher asking you in the class?
Those products to solve them, you have
Say
to
that
change
again.
the reaction. You have to
Change
change
the
the
reaction.
reactions.
Okay, write it down and send me a picture. And let's just any example of the question.
Sure. Okay, let me tell you. You have given this. For example, there is this ammonia reaction, right?
Yes, N2 plus 3H2 gives us ammonia.
We have to reverse this.
Reverse this. So this is what happens.
Yes.
If you reverse this, NH3
Yeah.
will come backwards and N2, 3H2 will go forwards. Easy?
But sir, she taught us something else.
What?
She said that the products goes on the right side and for example, if nitrogen is lesser, then the nitrogen will go to the product side. And if the product is less, then it will come to reaction side.
Yes, that is Le Chatelier's principle. Now, please read the concentration rules in your notebook and read it out to me about the summary of Le Chatelier's principle. The fourth and fifth, no, yeah. So fifth and sixth part on concentration. Read it out to me. I'll show it to you. I'll show it to you. Just a second. This one. Please read this one. Increasing concentration. This line.
Increasing concentration of reactants or products favor yield of products reactants.
What is the meaning of this? क्या समझ आया?
अगर reactant ज़्यादा होगा तो वो yield के products को favor देगा.
हाँ.
और
Okay.
अगर product हुआ तो फिर वो reactants को favor देगा.
Yes. So reactant होता है product के साथ, product होता है reactant के साथ. Now read the next one.
Decreasing concentration reactants products favor yield of reactants or product.
So इससे क्या समझ आया? What do you understand? English.
English. Increasing concentration between yield will still have the same reactants or same products.
Not really, not same. If you so look here, what's happening? The opposite must happen. Okay. Now, if you decrease concentration of reactant, what is the opposite of decreasing? Tell me. Opposite of decreasing.
It's increasing.
Increasing. So if you decrease concentration of reactant, then it will favor yield of reactant. If you decrease reactant, the reactant will increase. Is that clear?
Yes, sir.
If you decrease concentration of reactant, then it will favor yield of reactant because it has to do the opposite. That is Le Chatelier's principle, because if you do something, the opposite will happen. Now, what is the opposite of increasing?
Opposite.
So your voice is lagging.
Now, can you hear me? Zahra, can you hear me?
Yes, sir.
Okay, fine. Now, you tell me what is the opposite of increasing?
It's decreasing.
Decreasing. Okay, so if I increase reactant, what happens? Which side is favored, product or reactant? Let's focus. Let's remove these guys for now. Okay, and let's focus on these only. Now, if I increase reactant, what is favored?
Products.
Product.
Favored is yield. Yeah, for yield of
product. Yeah. So yield of product. So if I increase product, what will happen to reactant?
They will decrease.
Decrease. So ulta ho raha hai na, agar aap increase kar rahe ho, if you're increasing the reactant, then product is favored. Why? To decrease reactant. If something is increasing, then it will try to decrease it. How will it decrease it? By making more product. Okay. Let's try it again. Just a second. I'll give you some questions on this. Niranjana, can you hear me?
Yeah, sir. Now I can hear you.
Now you can hear me. Now let's try questions on just this. Okay. Now you tell me if you have a question like this. You have N2 plus, let's try something else. Let's say 2SO2 plus O2 gives us 2SO3. Now, if I increase, let's say I'm increasing concentration of SO2. Okay, which side is increased? Is increased. Which side is favored? Question, tell me.
Reactants.
No. First, we have to realize what is SO2. Is it reactant or product?
Sir, SO2. It's, sir, but you have written 2SO2 and then 2SO2. It's okay.
This is SO3. Right? This is SO3. This is SO2. Now 2 doesn't make a difference. इससे कोई फर्क नहीं पड़ता. That just tells us how much we have, how much SO2 we have. So Niranjana, tell me, SO2 is reactant or product?
Reactant.
Reactant. So if you increase reactant, okay, what is its concentration of reactant is increased. Now what happens? Which side will be favored?
Product side will be favored.
Product is favored. So now, so this I'll say the answer will be, according to Le Chatelier's principle, product is favored. Product side is favored. Favored is favored. Just a second. If conc of reactant is increased, then product side is favored according to Le Chatelier's principle. Equilibrium shifts. Which side will equilibrium shift? Forward or backward?
Oh, sir, can I ask a question? Okay.
Yes.
Okay. So here we have 2, and here also we have 2. Both are equal, right?
No. See, now we're not talking about pressure. You look at 2 here. The number of particles only in pressure. Now in concentration, you have to forget the number of particles. They don't make a difference. Is that clear? Okay. The only thing that matters is, अगर आप reactant increase करोगे, then SO3 will increase. Okay. So forward reaction is favored. Because what is written here? Read this. Product side is favored. If this is favored, then which side is product? It is forward. So equilibrium shifts forward. Okay, let's try another question just like this. Okay, now what I'm doing is I'm increasing concentration, increasing concentration of NH3. Which side is favored? Tell me.
Product side is favored.
Which side is
reactant side?
Reactant, the opposite side is favored. Okay. So what will I write? Okay, so reactant side is favored. So where is the equilibrium shifting? Forward or backward?
Forward.
Okay, let's see again. This is product. Okay. And this is reactant. If I increase product, what happens is reactant will also increase. Okay. And this will decrease. Okay, let's look at it like this. I'll show you one example. And Niranjana, try to answer this question if you can. What happens increasing concentration of NH3? Which side will be favored, Niranjana? Tell me.
Product side.
No, that's wrong. Try again.
Why?
Think.
So when the temperature is lower, we get more NH3. So
There's nothing about temperature here. कुछ लिखा है temperature के बारे में? नहीं. So it's all about concentration. Now look here. आपके पास पहले ऐसा था. This is what you had already. Okay. You have to balance here. Let's focus on this. Okay. Can you see the diagrams here?
Yeah.
Starting May, it was balanced. It was balanced in the beginning. So we had this N2 plus 3H2. Just a second. N2 plus 3H2 on this side. That is the reactant, yes? R. This is the product side. And this was balanced. Now suddenly, if I increase NH3, okay, how can I balance this again? NH3 has increased. What is the way to balance it? Make it go backwards to the to balance it again. Now let's focus here. NH3 is more, yes. One thing we can do is we can remove some NH3 and make it go in this direction. So then what will happen is it will balance again. Now talk to me. Tell me what is happening in the first diagram.
First diagram, it is balanced almost, but in the second diagram, the product side is more than the reactant side.
Okay, so what do you have to do now to balance them again?
We have to increase the
Increase what?
product side.
Product side.
Increase product side.
Yeah.
Yeah, so what will happen then? फिर तो ऐसे हो जाएगा. This will go even downwards. This is what you will have. If you more increase it even more.
We have to
Yes.
decrease the product side then.
You have to decrease, right? अगर आप और ज़्यादा इसमें डाल दोगे फिर तो और नीचे चला जाएगा ये. What do you have to do now? Tell me.
Decrease it.
Decrease it. How can you decrease it?
But sir,
How can you decrease the product side?
by giving some by
By pushing it up? No.
No, by a reaction.
By increasing this guy. So if this will increase, then what happens? This some of this will go to that side. Is that clear? So what you're doing is you're breaking NH3. You're breaking this NH3 into N2 and 3H2 backwards. So the reaction is now going backwards. Okay. So what will happen is now this will decrease and this will increase. समझ आ रहा है? This will break down and the more of this will come. And if that happens, then this will be balanced again. Does that make sense? Now we'll try another one of these. Just a second. Balanced again.
But sir, the question is about forward or backward. How come we will know that?
Okay. Now you tell me NH3 plus N2 plus 3H3. 3H2. Is this backward reaction or forward reaction?
It's forward. N2 plus 3H2 will be forward reaction.
So what is this guy then? ये क्या होगा फिर?
ये backward reaction.
Backward reaction, yes. उल्टा जा रहा है. It's now going back. Instead of going forwards like this, it's going backwards. Okay. So it's going backwards, and that is how we make it balance again. अगर आप एक side को increase करोगे, then it will want to go to the other side and balance out. Let's try another question. Let's say question number 3. Gives us what? 2SO2 plus O2 gives us 2SO3. Now in the beginning, again, you had a balance.
So, sir, can I clear something else too?
Yes.
अगर reaction उल्टा हो, so it's backward. अगर reaction आगे हो तो no, product side आगे हो तो it's forward, right?
Yes. Product आगे हो तो forward है. Yep. Now look, this is your thing again. It's balanced. Yeah. Now what you tell me? If I, let's say, if I do one thing, if I do this, now I increase SO2, we side with 2SO2 plus O2. Now how can I make it balance again?
Okay, so you have to increase the product side.
You have to increase the product side. How can I do that? By forward reaction or backward reaction?
By forward reaction.
Forward. Does that make sense now? Niranjana, can you answer this question? If I increase the product side, okay. Sorry, no. Just a second. Look at the question again. At first it was balanced, okay. Then I increased the reactant side. So let's say I'm increasing the reactant side. R went up. R went up, okay. How can I balance this? Again. If the reactant side is going up, okay, How can I balance this again? Tell me.
In the second side, either we can decrease the product side.
Decrease the product side.
We can decrease the product side or increase the reactant side.
If I increase the reactant side or, so then it will go downwards, yes? और नीचे चला जाएगा वो. Reactant को क्या करना है?
No. We have to make reactant side more.
More. So this will go even downwards. Zahra,
No,
Niranjana.
more than it will go down.
So I wanted to
So we
come
have
back.
to decrease the reactant side.
Decrease the reactant side. Or what? Or you have to.
Or
And
we have
what about
to
product
increase
side?
the product side.
So what?
We
Okay,
have
how do we
to
increase?
increase it.
Okay, which side is the increasing product side? Forward or backward? Which side is product? Forward or backward?
Forward, then we increase the
Forwards. So product is at the forward side. So I'll make it go forwards. So this guy will go downwards and this will balance. Is that clear? Zara, clear?
Yes, sir.
Let's try another one of this, just like this. I won't be making those diagrams now. I'll just show you. I'll ask you questions. Just like this. Question number 1. First thing is you have N2O4 gives us NO2. Okay. Now I'm increasing concentration of N2O4 is increased. Which side will the reaction go? Which side is preferred?
Okay, so sir, which is product side?
Say that again.
Which is product side?
It's always the right one. Product is always right.
Yes, but you okay.
Hamisha, it's like this. R and product. Niranjana, answer this question.
with the product side.
Okay, product side is favored. Okay, the answer is product side. Now, if I ask you, concentration of NO2 is increased. Which side will be favored?
Reactant side.
Reactant side. Any doubts now? Any questions? अगर आप इसको बढ़ाओगे, then this will also increase. To make this guy.
Your voice is lagging.
Now can you hear me?
Yes, sir.
Guys, can you hear me now?
Yes, sir.
Yes. Any questions on this part?
No, sir.
No. Okay. What about this one? If let's say you have again SO2 plus O2 gives us 2SO3. What happens if I decrease SO2 concentration?
Decrease the SO2 concentration.
Which side is preferred?
Product
Which side
side.
is favored?
Product side, sir.
Yeah, okay. Azahra says product side. Niranjana, what do you say?
So I will say the product side also.
Rejoin for a second. The answer is wrong.
Reactant.
No, I don't want the answer like that. I want the whole thing. So read from your notebook and tell me what is the answer.
Okay, so sir, does it include yield in this or not?
This is about yield, yeah. If
Yes.
forward जिस side जा रहा होता है उस side का ज़्यादा yield होता है, okay. If you go this side is yield is increasing. So read the point. Just read the point.
Okay, decreasing concentration of reactant favors yield of reactant.
So favors
Is it
yield
this
of
way?
reactant. Yes. So which
Yes.
side is favored?
Yield, reactant, sorry.
Reactant. Okay. Now, if I say, Niranjana, is this clear?
Yeah.
Okay. You tell me. Now I'm decreasing concentration of O2. So conc of O2 is O2 goes up. I'm increasing. Tell me which side is favored. Read the point, the correct point from your notebook. Based on this, Niranjana, read the point.
Increasing concentration of reaction or product favors yield of product or reactant.
Right, you're reading the whole thing, but now you first tell me what is oxygen here? Is it reactant or product?
Reactant.
Reactant. So what is being increased? Product or reactant? Reactant is
The
being
product
increased.
is
Zara, read the answer. Say the answer.
Oh yeah.
Zara, say the answer.
Sir, okay, so it's decreasing decreasing concentration of yield of reactants. No, reactants of yield of reactants. Is it this way?
No, it's like this. I'll tell you the answer. The answer is right now I'm increasing. है ना ये ऊपर जा रहा है arrow. So concentration of O2 is increased. So this is a reactant. So I'll say
It's product.
O2 is reactant. Yes.
Yes.
So if increasing the concentration of product will increase the which will favor the yield of product. Increasing the concentration. Let me write it here, or just read it from your notebook. I'll show it here on your book on the board. We're almost done. Just a second. This part right here. Read the sixth, the fifth line. Niranjana.
Sir, can you zoom in a bit?
Zoom in. Okay.
Low temperature favors
No, not the whole thing. Not the whole thing. The fifth line.
Okay. Increasing concentration of reactants or products favors
Stop.
yield of
Stop. Now it's not. You don't have to say both. देखो यहाँ पर वो ये है reactant is with product. So either reactant is increasing or product is increasing. Now in our question, reactant was increasing. Yes. So
yeah.
So we'll only read reactant. Forget the product side. Okay, this one. So it's reactant will increase favor yield of product. Product will favor yield of reactant. Okay.
Okay.
So read it again. Only the product, only the reactant here.
Okay. Increasing concentration of reactants favor yield of product.
Yield of product. Let's go to the question. Let's go to the question now. Here, O2 is a reactant or product?
Reactant.
So read the answer.
Okay. So
Zahra, say it. अभी जो निरंजना ने बोला वही आपको दोबारा बोलना है. Say it again.
increasing concentration of reactants favors yield of product.
Product. Now product is forwards. Yes.
Yes.
So we realize अगर अच्छा product is favored, so reaction will go forward. Now third part, I'm decreasing SO3. So conc of SO3 decreased. What is the answer?
Okay, so if it's decreased, decreasing concentration of reactant favors yield of reactant.
But is SO3 a reactant or product?
Is it it's reactant, right?
अच्छा, reactant कहाँ पर होते हैं? Left side पे, right side पे?
Left side.
Left side. तो यहाँ पे SO3 दिख रहा है आपको?
Oh, sir, I
No.
thought that you wrote this by yourself. I'm so sorry. Okay, so reactant is on. Okay, so decreasing concentration of product favors yield of product.
Product. So is this is
Yes.
the reaction going forward or backward?
It's going forward.
Forward. All right. Now, just like this, so far this one was correct. Good job. Now the fourth one in the same one. Now what I'm doing is I'm going to do concentration of SO2 is increased. Write the answer in the chat, Zahra. Niranjana, tell me the answer.
Sir, can I say it here because then I have to come back to the board and the chat disappears again.
So say it to me. But wait a second. Let Niranjana answer first.
Okay.
Niranjana, what is the answer? Zahra, say the
So
answer.
the reactant side.
Yeah. What will happen? Niranjana?
It will favor the reactant side.
Wrong answer. Zahra, you try.
Increasing reactant sides. Increasing reactant favors yield of product side.
Product side. So reaction is going forward or backward?
Forward.
Forward. Now does it make sense?
Yeah.
Yes.
Let's try one more in this. Fifth one. Concentration of SO3 is increased. Niranjana, tell me the answer. First, you need to realize what is the first step. You're skipping the first step. That is, first tell me SO3 is a reactant or product?
It's product.
Product. Now tell me the answer.
So increasing the concentration of product side favors the yield of the reactant side.
Reactant. Okay. So reactant favored. Good job. That's correct. Now then tell me which side is the equilibrium going? Forward or backward?
Backwards.
Backwards. Now let's write the equation for this as well. What is the backward equation? Equilibrium shifts backwards. So in the exam you'll write equilibrium shifts backward. Okay. Then the final thing is the equation. What is the equation of reaction? If it's going backwards, look at the arrow. It's going backwards. So what will the reaction be? It will be SO3, 2SO3 gives us 2SO2 plus O2. Is that clear?
Yes.
Yeah.
That's okay. Okay. Just one final one. Now you have to give all the 4 parts. This is the final one. Please don't mess this up. Okay. The final one with ammonia, NH3, let's say N2 plus 2 NH3. Should I give this question or not? I'm going to take 5 more minutes. Is that okay?
Yes, sir.
Yes, sir. Okay. N2 plus 2 NH3 gives us, not 2 NH3, sorry. N2 plus 3H2 gives us 2 NH3. Part 1. Part 1 is first, I'm going to ask you everything now. This is summary. Or this is your skill check, perhaps. Skill check. Okay. Now, first thing, I'm also telling you that this has this reaction. Okay. This enthalpy is this over here. Now, first thing first, concentration of, the question is, concentration of N2 is decreased. What the effect does this have on equilibrium? Now I need the answer on your notebook. Not, you don't have to say it. Write it on your notebook and send me a picture. This has 4 marks, by the way. And I'll also say that give equation of the reaction happening.
This is the most difficult part I ever found in chemistry.
So we'll make it easy. Find out what is difficult and make it easy. That is the way to get good at something. Realize what is difficult. You have done that part. Now I'll try to make it easy for you. Now, okay, which side is this is the question, sorry. Which side is favored? What effect does it have on equilibrium if equation of reaction happening? Now, this whole thing is for 3 marks. Yeah, solve it on your notebook. Done. For this question in the exam, you'll get only 2 minutes. Or actually 1 minute, 30 seconds. Because you get 30 seconds for 1 mark. Yeah. Doing, what is the progress?
Sir?
Yes.
So you mean to ask that what effect does this have on equilibrium? It will be you mean to ask that is it forward or backward, right?
Yes. But how was by the way, how was Saudi National Day? Did you go out on Yawm al-Watani?
It was so good.
It was so good, I see. Alhamdulillah for you.
There were fake Salmans out there getting the same getup of him.
So they had people who dressed up as King Salman.
Yes.
Wow, okay, that is new. I see. What else?
Okay, so
Write
they
the
were
answer as
having
well.
snow.
Yeah.
Yeah, I'm writing. They were having snow sprays and spraying on each other's and on the cars. And small children were giving lollipop while they were sitting in the car. And if we get a lollipop, we will throw it back into somebody else's car. Yeah, that's what I did. And there was a parade too. We joined parade, and that was fun.
Alhamdulillah. Now, when we used to there, we would drive around in our car with the Saudi people. Yeah, that was fun. We dressed up in green. Did you guys dress up in green?
No, sir, we were just having albums because as a grown up, you're not supposed to remove our mask. So we were just having albums, some flags in our hands and some scarves around our neck, and we would tie it and roam all the area. That's all.
Yes. That's cool. So that's amazing. Must have been kind of, what do you say? A lot of traffic, yeah?
Yes, we almost spent, I guess, 3 hours in a jam traffic, and people were crossing each other's road. For example, there was this huge car, and then they stopped every way for each and every person their way, and it was standing in the middle of the road, and it was a blocked road. And then there was this police, and he came and he talked to him, and then he moved his car slowly, and then we all went past.
I see. So the shurta saved you all, yeah? I see. Good.
Yes.
Now, have you written the answer? Niranjana, what is the progress?
So 1 minute.
So the time is over. Yeah, you need to focus on the time as well in the exam, because even if you get the answer correct, you have to have it in the specified time.
Sir, it's forward, sorry.
Now, just give me the answer, the final answer on your send the picture of the final answer. I'll check it.
No, sir, it's the right answer.
Okay, I've gotten the two answers here. Let's see. This is someone, and this is the other one. All right. Okay. Decreasing concentration reactant favors yield of product side. Equilibrium will shift forwards. Okay. Decrease. Okay. Reactant favors yield of product side. Equilibrium will shift forwards. Yep.
So it won't go backward because we will shift reactants with reactant, right?
Yes. Just a second. Yield will. No. Okay. This part is wrong. Okay. This is wrong, Niranjana. So sorry. Okay, shift forwards. No. Okay, Niranjana, let's you have done the you have written the answer correct. The whole format is good. Format is correct. Format is correct. Format is correct. That's good job. But answer is opposite. So not so good. Now, decreasing concentration of reactant side favors yield of reactant side. That's correct. So reaction will go backwards. This is the equation. Now, Niranjana asked me doubts here. Zahra, can you hear me?
Yes, sir.
The answer is correct. Okay. Decreasing concentration side favors yield of reactant side. So the only thing she got wrong was this part here. This one. Favors yield of product. This should have been reactant. Niranjana, can you hear me? She's joining back. Okay. So I think Zahra, this is clear for you. Yeah?
Yes.
Okay. Now, did you have difficulty with the reaction part?
No, sir. It was
No,
good.
that's good. Now, Niranjana, listen to me.
Okay, sir.
Now, please read your in your notebook. You have copied this wrong. This line. Read it again. Decreasing concentration of reactant side favors which side? Read it from your notebook. Tell me.
The
Right
decreasing
here.
concentration of product side.
No, look here. Decreasing reaction of the side. Just look here. Decreasing concentration of reactants favors yield of reactants. Niranjana, read the blue part here.
Decreasing concentration of the reactant favors yield of reactant.
This is what you flipped. You did this, favors yield of. So it would have been decreasing concentration of product favors product.
Okay.
That is the thing which you, so you understand?
Yeah, sir.
Right. Now one last question on this and we're done. Effect of temperature. So let's say what is, okay, let's just say high temperature is used. High temperature is used. Which side is favored? Which side is favored? And why? What effect does this have on equilibrium? Give equation of reaction happening. Write the answer in your notebook, send it to me.
Sir, what is the reaction or the product for number 2?
Same reaction, N2 plus 3H2 gives us NH3. Or I'll give you a new equation. Let's say the equation is, in this case, is SO2 plus O2 gives us 2SO3.
So sir, concentration and temperature are totally different, right?
Yes, totally different.
Okay,
We did
so
temperature
here we-
before. Use the temperature rule on your notebook. You can check the answer in your. So check the rule for temperature, and based on that answer.
Okay.
By the way, in your answer, you should mention Le Chatelier. Yeah. So he should be happy in his grave. Even for the part 1, even in each of these questions, I expect you to mention Le Chatelier. Now solve part 1 and part 2. For this, for 3, the reaction is, the equation is
Sir, do we have to do both?
yes.
Okay.
So can we just get the answer and no energy left?
Now you can't say the answer. I have to see it. Yeah. Because in the exam you'll be writing the answer. This is the last 2 questions. Finish them and you're done. There are 4 parts to this. You can't say it.
For this, we will write high temperature. So how will we write it?
How will we write it? You will say, you will see, check what is is it endothermic, exothermic? So based on the Le
High
Chatelier's principle.
temperature.
Yeah.
High temperature, it will be endothermic.
Say it again.
High temperature, it will be endothermic.
Yeah, so favors endothermic. So which side is favored?
The reactant side.
The reactant side is favored, the endothermic side. Okay. You can say both. You can say reactant side or endothermic side. Now, what effect does this have on the equilibrium?
The reaction will move backward.
So what is the equation of the reaction happening?
So that's the problem.
That's the problem.
Answer I know, but the equation not stuck.
Yeah, Zahra, have you finished?
No, sir, I'm still doing it.
Okay, so Niranjana, tell me the answer for the second part. The
Second
equation,
part,
the equation.
low pressure. Oh,
Not-
equation.
Yeah. Equation for the second
Equation,
part.
we will just write the same and just make an arrow to the reactant side.
No, not like that. No.
And
See, you did it correct previously, yeah? So you can do it again. Now they're asking you where is the equilibrium moving? You said backwards. So write the reaction. Write the equation. Solve this one.
so how to do that part?
Look, it's this. Okay. It's going. The reaction is going backwards. So it will just flip the reaction. Flip the sides.
Sir, is it this way?
Send the answer. Have you sent it?
Yes. Just for number 2 and number 3, I'm going to do it.
Okay, Niranjana, start doing number 3. The answer for the second part is since it's going backwards, the answer will be SO3 plus SO3 gives us 2SO2 plus O2. Done? That's it. Let me check. Just do the last part. That is the last question. Last question. Okay. Finish it. Zahra, I'm checking your answer.
It's okay.
Decreasing concentration of reactant side favors yield of reactant. No, that's okay. This one. High temperature favors endothermic. So according to Le Chatelier's, equilibrium will shift backwards. Yep, that's correct. Good job. Is that clear? Any doubts in this?
Also,
Now, finally, the last question.
Sir, for question number 3, should we use Le Chatelier's principle again?
Yes, for all three: concentration, temperature, pressure. You have to use Le Chatelier's principle. Yep, it's a French name, and CH is Shah, not Shah.
Sure.
His full name is this: Henry Louis Le Chatelier.
Le Chatelier is better.
Yes, you don't have to write the full name. Yeah, just write Le Chatelier. He made all of this. I think I'll finish the question first. Yeah, so he made all of these rules in 1900. Almost 122 years ago. Done, Niranjana, have you finished?
1 minute, sir.
Sir, can I ask a question?
Ask.
So here, CuSO4.
Yes.
C will be 1, right?
Just look at the
And
numbers
then-
in front. Numbers in front. Okay. Not the small numbers, but the large ones in the front always.
You mean before the reactant,
Yes.
right?
Before
Like-
the reactant. Yeah. Before the chemical, the compound. The small guys, they are not counted. These guys. They're small. They tell us what compounds are in the molecule. They don't tell us how many molecules we have. The big ones in front here, that tell us.
Side with less particles. Okay, so according to the Chatelier's principle, will shift backward. So 4. Okay. Sir, done.
Done. All right, let me check.
Okay, this was a confusing part. I don't know why. I don't get it.
Now CuSO4 plus H2O. So product low pressure favors yield of products yield side with less particle. Okay. Less particles according to Le Chatelier's principle, equilibrium shift backwards. CSO4. Yep, correct. Good job. 3 out of 3.
Oh,
Right? Does it make sense now? Is it easy?
so if it is with the load, then it will go backward. If
Wait,
it
no.
depends,
This is, let me check. Now, low pressure favors, okay, accordingly, it will shift backward. Fine, this is correct, but this is wrong. You wrote the rule wrong.
so it's low pressure favors yield of product side with less particles.
No, that's wrong. Whatever you have written here is wrong. Check the note on your notebook again. Check the rule in your notebook.
It's
This
low
part.
pressure.
Yeah, low pressure favors with side. Side with part with.
With more particles. Oh,
You wrote
yeah.
less.
Sorry. Yes.
How did you get this correct then?
Yeah, it's wrong.
So if you wrote this less, you read it, wrote it wrong. So how did you get this part correct?
Yeah, it's all wrong.
That cannot be all wrong. This is correct. No, this is correct. Okay. This side is correct. So you tell me first which side has more particles? The reactant or
But,
product?
reactant.
It has more particles too. This has 1. So this will go backwards. That's what you did. So that's correct. So just don't write, make sure that you're writing everything correct. Okay. This is wrong. So that's all for today. Now I'm waiting for Niranjana's answer. Both of you stay for a second.
Okay.
Now, according to Le Chatelier's principle, low pressure favors yield with more particles. Yep, that's correct. That's correct. Equilibrium will shift. Okay. This side is this one is wrong. Now, Niranjana, work with me. Tell me what is wrong here.
It will move backwards.
Why? Because you look here. This is 1, this is 1, and this is 1. So this side has how many particles? 2 particles.
2 particles.
This has 1. So where will it go? More particle side.
It will go backwards.
So why did you write forwards? Yeah. Why did you write backwards? So please make sure to check that you're following the correct rule. You're writing the rule correct. This whole part is correct up till here. Okay.
Okay.
So just make sure you follow the rule and measure the particles correctly. Now that is all for today. Now one last thing. If there's anyone who's interested in joining you guys and studying with you, perhaps any of your friends, please ask them.